Welcome, everybody. Can you all hear me all right? I'm using a different setup than usual.
Yeah, I can hear you.
I can too.
Okay. Let's see. I had to turn the audio up on the laptop so I could hear the answer. All right, I think everything's probably ready to go. All right, so you should be able to see the microprobe lab here, or part of it anyway. And I also have literally a box of rocks. So we need some samples. And so let me scroll down here on Blackboard. All right, so sorry, other unit. There we go. All right, so this gets us beginning on lab 8. So of course we have the pre-lab tomorrow, and then as it says, intro to using the microprobe to help us out with rocks today, and of course the main lab on Friday. And again, we'll be meeting in person for lab this week. And just as a reminder, of course, there's this Igneous Lab chapter, which actually I think I'm going to put into the browser tab. Might want to come back to that further along. And then I need to scroll down. So first there's the pre-lab, which you'll want to do tomorrow. And this has pictures of a few rock samples in it. There's one there, another one there, and another one there. So I'm going to pick different ones for what we're going to do now. So I have a different set of samples, and we'll match them up with what you'll actually have in lab on Friday. And we also have this that one, lab worksheet. There we go. I was just clicking on the wrong one. Okay, so we have this one that uses the worksheet. So this probably looks a little bit like the one we had last week for minerals. This has different characteristics in it, but it's basically the same idea, to go through and collect some data, observations about the different rocks, and figure out what kind of rock it is. But there's an item in here called minerals present. And having looked at some minerals already last week, you have a start at being able to recognize some of them already. Of course, I mentioned on Monday, we can also use the lab key and the chapter and all of that to give us also some ideas of what might make sense for a particular kind of rock. But we can, of course, also do this with chemistry, just like we did last week with the minerals. And so that is where we're going to go. And so if you don't have a copy of this sheet already handy, maybe just grab something you can take notes on, because the minerals that we figure out today on the rocks, you might as well include in your lab on Friday. Because we're going to look at some of the same samples. Get that out of the way. All right, so next, pull this other window down. So I have a sample holder in the microprobe. And again, let's see, where is the camera? The other one is not showing me the camera. Maybe I'll turn off the screen share for a second. Trying to get it to show on the laptop what is actually going on here. So this is one of these little brass holders. We have 3 or 4 of them. we put the samples in. And the one that's in the microprobe right now is the same one that we had last week. The lower left corner, which would be this position, had the one with the little mount with all the minerals in it. And then there's 4 other positions, and they also have igneous rocks in them. This has, the one I'm holding actually has other stuff. It's volcanic ash and whatnot. But the picture, which I'll pull back up again. The picture here is just an image of that holder. If I scroll down, you can see the corner where the mineral stuff is. And there's, again, 4 different rocks in here. So there's one that says rock O. So I can scroll around a little bit easier. And then there's rock E and P and M. And so we're going to do probably, I think, just 2 of these for now. If we have time, we may do a 3rd one. We'll see how it goes. So let's start with rock O. So I'm going to double click on the picture. This is set up for navigation, so I can just click and it will go. But I also want to show you what an actual chunk of the rock looks like. You'll get a better look on Friday. Okay, it's driving and driving. Let's see. Stop the share. And so you'll see the picture bigger. So this is rock O. There's a little label on there. The label is just literally just white out and Sharpie marker. It works. It's easy, it's cheap, and it works. So we tend to do that a lot around here. And so you can see it's a fairly dark colored rock. So that's a useful clue that it's probably a mafic rock. So you might want to write that down too. And there are, I don't know if you can see, yeah, if I get it close enough, there we go. You can see there's crystals in there. There's some white ones, but maybe a little harder to see. There also are some green ones. Okay. So that means there's at least 2 different minerals that are big enough that we can see. Okay. All right, so that means we're probably going to want to try to figure out what those 2 minerals are. And again, you could try to do it just based on the color. It's like, okay, there's a white one and a green one in a mafic kind of rock. What options might fit? Okay, and there's a short list of things like olivine and plagioclase and amphibole and pyroxene and so on. So which of those are most likely to be white or green? And we could probably narrow it down pretty quickly that way. But let's see what we get with some chemistry. But we're going to do a little bit more than that. So last week, I just put the electron beam from the microprobe just on an individual spot, and we got a spectrum, an X-ray spectrum that showed us what chemical elements were in there, like what the elements that made up the mineral were. Well, and I also think I demonstrated briefly like the idea of scanning the beam so we could get one of these electron images. Maybe you've seen those kinds of things before from an electron microscope. It turns out we can actually combine those 2 things together. So we can do the scanning to make a picture, but also collect the X-rays at the same time. And so that is what we're going to be using today. So here's our picture. Let's see, I'm going to look on here. It's a little bit dark. Let's see, there's a big crystal. Well, one of these big crystals. I think this might be one of the white ones. So I'm going to double click on one of the white ones. What I think is one of the white ones anyway. All right, so then I'm going to go to the other software. And share screen back on. Okay, now it should be showing. All right, so there's our rock. The picture is that the actual size is 1 inch round circle. And we can kind of see that there's some crystals in here. If the image was a little bit brighter, that might be easier, but there's some crystals in here. And there's a little cross mark, little purple marker here. So that is showing where we are on the same. So we can go and aim at something in particular and know where we're at. All right, so I'm going to go over here. And I'm just going to do a preview to start with. There's a preview image. All right. Well, maybe the thing I clicked on isn't actually a crystal. Actually, it looks like a hole. Okay, so that actually might be worth noting too, because one of the things we often look for in volcanic rocks is whether they have bubbles or had bubbles, which are now, well, since it's solidified as a rock, it's now a hole. But it would have been a bubble of gas in magma or lava, and now it's just a hole. So apparently there are some of those in this rock. We call those vesicles, so that would probably be worth noting down. But it also means that I need to probably pick a different place, because I was trying to get a crystal, not a hole. Let's try another place. Oh, there's another hole. Okay. Although I think we can kind of see there are actually little crystals down inside of there on the surface, which is kind of cool. Let's see, better focus. Yeah. So yeah, there's actually a whole bunch of little tiny crystals lining the surface of that hole. That's pretty cool. Yeah. All those little kind of flat sides and kind of rectangular shapes. Yeah, those are all tiny little crystals on the surface. Lots and lots of them. That's kind of cool. I've never actually looked in one of these holes this closely before. Usually I'm just going and trying to find other stuff. But yeah, it's just covered with tiny little crystals in there. Let's see, let's try something else. Let's do, find, maybe we'll just go to one of these big things, like the corner of one of these big things. I think this might be the edge of one of the green ones. There we go. Yeah, we're on the edge. Okay. Here, so I can turn the motor manually. So there's this, what looks like a big crystal here, and I picked a spot next to the edge of it, and it looks like it landed in the right place. So there's another one of those little holes here. Looks like kind of like a crater. I think actually I see crystals down inside of that too, little ones. All right, so there's part of our big crystal. And it's by the scale of what the microscope can see, it's enormous. But right next to it, you can see this area with lots of little crystals in it. They're sort of bright, long things. So those are microscopic crystals. Like if you were looking at the rock with just your eyeball, you wouldn't even be able to see those. Okay. So we have here what we would call like some big crystals. You can see there's a huge difference in size. The large ones don't even fit in the view. I could zoom out so we can see more. But still, it's just not going to all fit. It's like a couple of millimeters across, and the microscope can't actually zoom out to see something that wide all at once. But then the stuff in between, like all those big crystals, well, there's some holes in there, and then there's all kinds of little tiny crystals. So there's more of that area with the microscopic crystals. So we call that the matrix. So if you have a rock with big and small together, the big crystals, if it's an igneous rock, would be the phenocrysts, and the tiny ones in between would be the matrix. So this has big and small crystals together. So we just learned something about the texture. So this rock is porphyritic. We probably want to write that down too. I already told this thing to update twice today, and apparently it needs more. All right. We'll have that later. All right, so what is this stuff? Well, let's see. Find a spot. Get a little of everything. So we've got part of that big phenocryst crystal off on the right side, some of the smaller matrix crystals, and one of those holes for good measure. I'm going to zoom in and make sure everything's focused nice and sharp. We don't want a blurry picture. I think that's as sharp as it's going to get. All right. So we've got our live image. And so the next thing I want to do is actually get the X-ray part. So I need to go to a different place in the software. And let's see, I need to set, we're at 300 times magnified. So I'm going to tell the computer that. And I changed a couple other things. That's the same. Okay. 1,000. All right, so 300 times magnified. All right, and this is, says this is rock O. So I'm going to put in a label, rock O. And let's do, I'll just have it take a snapshot. I may not necessarily have to do this one. I just want to make sure the software isn't going to complain about something else later. All right, let me see. Actually, I'm going to turn off one other thing. So I haven't, there's another camera in here that I have on. It's the, let's stop this. All right, so up above, up. On this computer monitor, I have the image from the camera that's on the optical microscope. So there's a eyepiece, literally like 2 eyepieces. You could actually look in here yourself. And there's a camera and it feeds up there. And usually we use that to make sure things are in the right place. But when I try to do a nice image, the light bulb that's for that, it's actually an LED. Causes a little bit of flickering in the image, so I'm going to go and turn that off. And then let's back down. Something like that. All right. So I'll have to readjust the brightness, but I was noticing it was kind of giving me this little ripple interference pattern on that image I just tried doing. So we don't want that. Let's turn up the contrast a little bit more. I want things to pop out a little bit more. Okay. All right. So that looks like that's ready to go. Keep the contrast up kind of high, but that's okay. I want to be able to see the differences between things better. And we got rock O in there already. And okay, let's see. All right, so we should be ready to start. So I'm going to hit acquire here. And there we can see it bringing in the electron microscope or scanning electron microscope image. Looks like I've still got a little of that kind of ripple going on. That's okay. Something's causing a little bit of interference probably. All right, so we can see in the big crystal on the right and that matrix of microscopic crystals on the left. There's a scale bar here. It says 60 microns. So that width of that is pretty close, actually. If you pluck a piece of hair off your head, that's about how wide it will be. Okay, so this is really small. Okay, so that 60 micron scale bar again is roughly in the ballpark of the width of a strand of hair off the top of your head. So this is, yeah, these crystals in here are really pretty small. And we can, if I go and zoom in on this image, there's actually quite a bit of fine detail in there. We look in there, there's some crystals, I mean, they're like, even at this magnification, they're itty bitty little specks. Okay. Those might be 100 times smaller than the width of the hair on your head. Again, really small. Well, there's another thing we can do here, and that is go to this little periodic table icon, click automatic, because it's been collecting X-rays this whole time. And it's gone and tried to figure out what elements it thinks are in there. And of course, by default, it likes to turn them all on at the same time. And you can see it kind of makes a mess. It's just a bright blur, really. So I don't really want it to do that. So I'm going to go out of that full screen mode. Now we can see the bottom, a whole bunch of different little colored images. So each one of those little colored images is for an individual element. So I could turn these all off and maybe just pick one like potassium. So this is showing where there's high amounts of potassium, which would be bright, and low amounts of potassium, or maybe none at all, which would be dark. And we can see there are some bright things that have a bunch of potassium and other places where there isn't. We could do the same thing for other elements. We look at sodium. Clearly our big crystal on the right really doesn't have much sodium in it. Same thing was true in calcium. And the big crystal on the right doesn't look like it has calcium in it. But there are definitely some rectangular crystals in here that show up really brightly in calcium. And again, we can do this with other elements like aluminum or iron. Looks like that crystal on the right has a decent amount of iron in it, especially maybe right along the edges, which is interesting. Magnesium definitely has a lot of magnesium in it. And we can do silicon. We could even do oxygen. Looks like there's oxygen more or less everywhere. And then there's our electron image again, and we can combine these together any which way we want. So I could do, for example, the iron and maybe the calcium and put it all together. So this is kind of one of those places where geology and art can meet up, because you're taking the natural chemistry of the rock and minerals that are in it, and the texture of the rock, like the sizes and shapes of the crystals, and then you can actually change the colors. So I could make the iron be dark blue instead of purple, and you can like mix and match this and make something that might be considered art out of this. So behind this scanned image, there's X-ray spectra all the way around. Every single little tiny pixel or item in this image has that whole spectrum behind it. And I can tell the software to show us what that looks like. So for example, the big crystal, I could draw a box. And then this will get me the spectrum from that particular thing. And then at this point, it kind of looks like what we did with the minerals last week. We get a spectrum and use that to try to figure out what this is. And it looks like, based on the chemistry, this really is the green mineral that I was hoping to get to. This has iron in it, has silicon in it, magnesium in it, and oxygen in it. So this is the mineral olivine. And in most of the time, if you're dealing with igneous rocks, the mineral olivine is usually olive green, which is a good way to remember it. There are some other kinds of rocks where it might be a much darker color, but if you're dealing with igneous stuff, almost always olivine is olive green. So that's a useful way to try to identify it. So, all right, so we have olivine. What's this tiny stuff? I'm going to zoom in here. We can figure out what those little tiny specks of crystals smaller than a human hair are. So like these down over here, these rectangular green ones. And looks like there's two different things, a little bit brighter blue in the middle and not quite so much on the edges. So I'm going to actually do the center part. And then I'm going to do this thing off to the side, which looks slightly different. Another little tiny crystal there. And that's probably most of what's here, although there's some stuff that's showing up gray because it's not any of the elements I've selected. Oh, and that little bar that's kind of going by is because the computer is still having the microprobe scan and collect more data. So it's just showing the progress of it. It's still scanning and scanning and scanning. Okay, so I can take these three areas that I just added, and we can do the same thing on those. Do automatic to identify the elements, and you don't always believe what the computer tells you. It's identified boron, it's wrong. There's not boron. So I'm going to turn that off. You can't always trust the computer. All right, so this one, calcium, silicon, aluminum, and sodium. This is plagioclase feldspar. And it's actually the same as the big white crystals in this rock. So actually, I don't have to go looking for any of those. We've already got the mineral here. So it's both in the big crystals and in the small crystals. All right. Next one down, iron, silicon, magnesium again. That's another olivine. So it turns out the olivine is both big crystals and small crystals in the matrix too. And then there's another one that looks really similar to the olivine, but it has some calcium in it. So I can see there's a spike here of calcium in the middle. That is probably pyroxene. And that's actually another common mineral in igneous rocks. Actually, dark ones, medium ones, and light ones, but especially the darker ones. All right. Just put it on our electron image by itself. And we could do other combinations of things. All right, so we have 1, 2, 3. We've actually identified 4 different minerals. So again, this is rock O, and it has olivine in it. That's what one of the big crystals is, the green ones. It has feldspar in it, which is the big white crystals. And then both of them are showing up as tiny crystals as well. And then we also have pyroxene among the tiny crystals in the matrix. So on Friday, we'll put those things together, the dark color, the minerals, the texture, and we'll add in what kind of rock it is. So I'll leave you in suspense until Friday, but you can probably guess what it is. All right, so I'm going to save this. One, rock, oh. Say. So this kind of thing where we have the X-ray image like this, sometimes people will actually call it an X-ray compositional image because that's what it's showing. But a lot of times geologists call it an X-ray map because it covers an area like a topographic map would cover an area. Let's pull up navigation again. Let's go to the other rock. like somewhere maybe over here. So this one, rock E, maybe you can see there's a little white patch and the rest of it looks maybe a little bit brown. So the whole rock got coated with a little bit of a film of carbon. Most things that go in here, if they're not metal, we have to put a carbon film on them so they don't build up a static charge, because that would make a mess of trying to do any analysis. But there's one little spot on the side of this where like a piece of the rock got chipped off afterwards. So this little white patch doesn't have the carbon film on it anymore. And so you can actually see the difference. So that little bit of a brown cover is just a layer of carbon. So that was added on purpose. And there's other things. There's a little piece of, you can see like something that looks maybe a little bit like shiny copper metal. That's because it is. I actually use copper tape to get, also to make sure things get connected electrically, because we don't want to build up a static charge. All right, so that's where we are. It looks like there's some kind of crystal here. Go preview. Let's go tell it. Maybe I'll put that on the other monitor so I can get to it easier. Right. I need to tell the computer to give me control so I can move it around myself by hand. All right, so it looks like, actually this looks like a pretty good spot. I think I don't need the contrast up so high, but there's three different things here. We have one that looks kind of a medium gray. Another one that's a little bit brighter, kind of has a rougher surface. And then something else over here that's showing up really bright. Unless that's a hole. I hope it's not a hole. Maybe that, actually that might be going off the edge. But that's what that is. I think that just went off the edge where there's no carbon film. Okay, we don't want that. So there's two things here. I think that was off the edge. Okay, I'm going to turn the contrast down over a bit. I think this is too much. And adjust the focus. You don't want it all blurry. There we go. And I can see tiny little details again. Is that actually going off the edge or not? I'm not sure. There's definitely a hole over here. Looks like a big piece got broken, chipped off or something. Let's see, where are we exactly? There's some kind of, all right, that mineral. Okay, this might be a good spot somewhere around here. Let's look like there's some bits, pieces missing. Oh, here we go. This might be even better. I think we might have a third thing. All right, this might be three different minerals. Zoom out a little bit here, just so you can see a little bit larger area. So yeah, so there's different things. But one of the things we can see, the texture of this rock is different. We don't have any areas with tiny little microscopic crystals. And then we've got this, which is pretty big. We've got that, which is pretty big. And we got this one, which is another mineral, which is also really big. We don't have those tiny little things in there like the other rock did. So this rock is almost entirely big crystals. So that means it has a different texture. So we'll call that phaneritic or coarse. So let's go back here. Get the different things all together in one image. So this is rock E. I'll change this to say rock E. Tell the computer what our new magnification is, because I turned it down a little bit so I can see a bigger area because we have big stuff. And All right, let's do acquire. Get rid of the old boxes. We don't need those anymore. So it remembered the elements we pulled up before. So I think that's probably okay. Let me double check that we're not missing anything important. Silicon, aluminum, iron. Yeah, that's most of the main things. I could turn on titanium and I could turn on phosphorus. There's a chance we might see something with that, but I kind of, but maybe we'll see. All right, so again, it's collecting the image. We can see the progress. We can see the little colored boxes down below showing each different element. And again, we have different elements in different places. We've got something there that's high in magnesium. And it turns out it's also got quite a bit of iron in it. And we have some things with potassium in them. This looks like this is a good spot because we've got a whole bunch of stuff. I can turn on silicon. I can see that they have the different minerals here have different amounts of silicon. And so if I turn on, I'll do the blue. What else? We can do potassium. We can do aluminum. That looks kind of. I don't think we're ready for Easter yet. That's, all right, that might kind of work. So from this, we can see that we actually have at least 4 different minerals. The kind of the long, narrow one I thought actually might be the same as what was on the bottom, but they're not. After all, so okay, so we have 4. So this actually is a good place. You can get the three of the most abundant minerals in the rock, and then an extra one all together. So what are these? All right, so let's try this one. Draw a box on there, and then draw a box on this one. See what that is. Draw a box on this one. See what that is, and then this one here. Long skinny one. There, long narrow crystal. I'll get that. So there's 4 different minerals. Let's go and look at our spectrum. Turn on the elements. All right. It looks like a mess with them all at once. So we can go through one at a time. Okay. And don't believe the computer again. It thinks there's tin in the molybdenum, which is no, not there. Let's make those go away because that doesn't make any sense. All right. And actually, I'm going to turn off that aluminum. It's not really, there's no really significant amount. So it's basically a bunch of silicon and a bunch of oxygen. So this is one of the most common minerals of all. Everybody knows it. Some people have a little crystal of it they might carry around. It's also usually, like if you're on a beach, oftentimes it's the #1 ingredient in the sand on the beach. So this is the mineral quartz. It's like, all right. So I'm thinking, go to Blackboard here for a second. All right, so again, we can noting in our textures and our minerals. And I want to go to the chapter. It's like, okay, yeah, the first rock, the dark colored one, we had olivine and pyroxene and the plagioclase feldspar together. So that puts us over on the kind of right half of the little chart here. And now we have a rock with quartz in it. So that means we're in the left half because there's quartz here. It could be either one of these felsic ones or one of these intermediate ones. So the other minerals we might expect to find to go with it might be alkali feldspar, plagioclase again, amphibole, or mica. So we'll see what we get if we get any of those specific ones next. So here's one. So this one has a lot of potassium in it, silicon, aluminum, oxygen, and actually the computer missed one because there's a little bit of sodium here. It's the one labeled Na. I'll stretch it up. There's a little tiny bump there. So I pointed out the sodium because it's actually important to figuring out what this one is. So this turns out to be alkali feldspar. Lots of potassium and sodium to go with it. Again, you could pull up the mineral identification chart and find these in there and then see the elements that go with them. All right, this next one also has the potassium, the silicon, aluminum, and oxygen, just like the last one, but they're not the same. So let's see, there's maybe some differences. This is not, the computer doesn't always pick the best color schemes. Maybe I'll do black and red together. Again, you can see they're different. There's different amounts of, there's the alkali feldspar. It has more silicon in it. It's higher on the silicon. It has less aluminum in it. It's lower on the aluminum. And the other one is the reverse of that. The other one, the new one, also adds some magnesium here. If I move over, there's some other stuff way out here. If we keep going, eventually there's iron. Let's scroll back in. Okay. So that's something a little bit different. That is mica. There's two kinds of mica. There's the light colored mica, the muscovite mica, and the dark colored brown or black mica, the biotite. We had both of those in the mineral kit last week. So I'm going to not label that one just yet because I think we actually have both of these micas here. So here's the other one, that's the longer, skinnier crystal. So this one, again, is the potassium, the silicon, aluminum, and it's similar to that first one. But again, we can see there's different amounts. The potassium is actually about the same, middle, but there's a big difference in how much magnesium there is and how much iron there is. And oftentimes, magnesium and iron go with darker colored minerals. So that would mean that the one with the high magnesium and high iron, which is the blue one here, that's going to be the dark colored mica, the biotite. And then the one with low amounts of those is going to be the light colored mica, the muscovite. And then I can go back to the map, and now they're all labeled. So those are our four minerals in this rock. Looks like we didn't run into any plagioclase this time. There is some in here. I could go hunting around for it. One of the interesting things that you can do with this is, if we go, let me go back to Blackboard for a second. So this diagram, if I zoom in on the part that says plagioclase, notice it has some extra labels on here. There's a place where it says sodium rich, Na stands for sodium, and another place where it says calcium rich, so Ca for calcium. And notice it's pointing towards one end having more sodium, the other end of plagioclase having more calcium. So actually the chemistry of the mineral plagioclase changes depending on what kind of magma it formed out of. The chemistry of the magma and the kind of rock that you get from that. And I'm not sure we have enough time to go looking around for it, but I've done it before. So the plagioclase feldspar that we had in that dark colored rock was high in calcium, but it didn't have very much sodium to go with it. And there actually is plagioclase in this this rock E. If you look at the picture, there's a lot of white in there. So that's probably from plagioclase. We just happened to land in a spot that didn't have any, but it was a good spot anyway, because there were other things there. And so if we get the chemistry out of the plagioclase from this rock E, it's probably going to be down here at the sodium-rich end, because we've got alkali feldspar, we've got quartz. So it should be at the end that matches with those. And so it'll probably have high sodium and low calcium instead. So I'm going to save this. Save, so that's rock E. Save. All right, the computer do its saving. And right now we have just a few minutes left. I guess I can hold up. I have a chunk of rock E, but turn off the screen share. I can hold it up. So this is what rock E looks like. And again, if I put them side by side, you can see there's a pretty big difference. One of them is a lot lighter and one of them is a lot darker. And so we have rock E with the alkali feldspar, the quartz, and actually turns out two kinds of mica, this particular piece of it. And then the rock O, the dark one with the pyroxene, plagioclase, olivine, and let's see, pyroxene at there was at least three. I was thinking maybe there was more. Maybe I'm forgetting something. Anyhow, the big green olivines, the big white feldspars, and then all the other tiny stuff in between. And of course, there are other rocks. I have another one, rock P, which is what's in the middle. We don't really have quite time for that. But it's actually, as far as color goes, I don't know how well that shows up. Maybe not bad. But you can see it's kind of in the middle for color. There's rock E, which is light, rock O, which is dark, and P in the middle, which is kind of an intermediate color. And so I'm all set up to do kind of the whole spectrum, but I don't think we have quite enough time. Are there any comments, questions, curiosities? Anybody want to come in here and actually use the microprobe? We have students do that all the time.